11.1 Dilations, Geometry. Essential question: how does a dilation transform a figure? The answer: a dilation changes the size of the figure without changing its shape. So the image is similar to the pre-image, but not congruent. So in simplest of terms, you have a circle, all right, pretend that's a circle. We go ahead and dilate it. And then out comes a bigger circle. They're still circles. Both of them are still circles, okay? But in terms of congruency, their distances are not the same. One's radius is a lot bigger than the other guy's radius. See, it's so small I could barely write it in there, okay? So they still stay the same shape, just not congruent. Doesn't preserve distance, and that's one of the properties of dilation. So let's get into the definitions. A dilation is a transformation that can change the size of a polygon but leaves the shape unchanged. So in example 1, you're going to see a triangle, okay? Let's go ahead and say that this triangle has a dimension like this, and that's a terrible 3. Okay, so let's say the line segment of this triangle for AB has a distance of 3. BC's line segment has a distance of 2. And AC also has a distance of 2. Okay, we're going to go ahead and say that the angles, since we got our sides, let's talk about the angles. This angle right here, okay, is 40 degrees. And these two angles are both 70 degrees. Okay. All right. So you have this triangle, you know its dimensions, you know its angles, and all of a sudden you stick it into the dilation machine, okay? And the machine, you throw it in there, and the machine's making its noise, and all of a sudden out comes your new image, okay? It's still the same triangle, well, kinda. It's still a triangle, but something changed, okay? So let's look at the angles. Now, if you had a compass, you would realize that the angles, they stay the same. Okay, that's still 40 degrees. All right, for ACB. Angle B, that's still 70 degrees. Okay. And angle A, it's still just 70 degrees. All right. So the degrees stayed the same. The angles stayed the same. But obviously it's a small triangle, so let's look at its sides. So looking at the sides, if you were to measure, you would notice there would be some differences. So if you remeasured AB, you'd probably measure somewhere around 1.5. Okay. If you measured BC, you'd measure a distance of 1. And AC, if you'd measure, would also be a distance of 1. Okay. Well, what changed? The distance, didn't it? So note that dilation, it changes, it can change the side, whether it's bigger, smaller, or even the same side. Okay, if you have a scale factor of 1, and then we'll get to that, the object will stay the same. In this case, it did not. It got smaller. So, how much smaller? Well, in comes our next definition, a scale factor. All right, a scale factor is the ratio of the length of corresponding sides in the image and the pre-image. Okay, so your image is the one to the right. Your pre-image is the one before you threw, the object, the triangle, into the dilation. So here we are. We're going to set it up. They say a ratio. Ratio is another fancy word for a fraction. So AB was a length or distance, or I'm sorry, A prime, B prime was the distance of 1.5. Okay. And the distance of AB was 3. Now, if we reduced, you would actually find out that is just 1/2. Okay? Let's look at A prime, C prime. A prime and C prime, that was both the distance of 1. And AC from the pre-image was 2. Oh, another 1/2. That's interesting. So let's look at the other sides. B prime and C prime was a distance of 1. And BC in your pre-image had a distance of 2. So as you notice, a scale factor is a constant change that occurs with all the sides of your image. Okay? If one side doesn't go through a scale factor, it's not going to preserve the same object, and you're dilating wrong. Okay? So that's what we mean by a scale factor. Again, a scale factor has to occur constantly to all sides. So if that isn't happening, okay, something's wrong. So remember, a scale factor is the ratio of the length of corresponding sides, all the sides, in the image and the pre-image. Example 2. Dilating the line segment AB with a center of dilation at the origin, 0, 0, and I'm going to call it 0.0 or 0.0, with a scale factor of 3. Okay. Also note, the definition of the center of dilation is the fixed point about which all other points are transformed by a dilation. So the center point, or the center of dilation that I'm going to make, is 0.0, right here. Okay? 0, 0. So that's 0.0. All right, it's a terrible O, I know. But that is going to be my center of dilation. Now, line segment AB, I'll go ahead and make it right here. So here is point A, and here is point B. Now, when you are dilating in a coordinate system with specific coordinates, it's actually kind of nice visually. If you didn't have this, you would have to use a ruler. Okay, so coordinate systems can be quite, helpful. So let's go ahead and dilate this like they prescribe. So we have to dilate by a scale factor of 3. Okay, so notice your point O is right here. Okay, its distance from O to A has a distance of 1. But now they're saying we're going to dilate AB by a scale factor of 3. So what's 1 times 3? Okay, you already have your distance of 1. So what's 1 times 3? Well, that's 3. So your distance is going to be 1, 2, 3 times further out compared to A. So your new point, okay, is going to be for A prime 0, 3. Now let's talk about B and where B prime is going to be. Notice how the distance from O to B is, well, is that right there, that little mark. Okay, but now we're going to go 3 times that. So 1, 2, 3. And there's B prime. Okay? So your new line segment, and this is the answer, the new line segment, after you dilate AB, okay, it's going to be right there. Notice the distance of AB is originally just 1. Okay, the length of AB is just 1. But the length after a scale factor of 3 for the new image for A prime, B prime is now 3. Okay, that's usually a dead giveaway that your scale factor is of 3. Okay, now if it went the other way, if it was originally 3, but then you went to 1, now your scale factor is 1/3. Okay, because 1 is 1/3 of 3. Okay, so it can go either way sometimes, in your homework especially. You can get bigger or you can get smaller. It just depends on your scale factor. Okay, so example 3. Now we're dilating the line segment AB with the center of dilation at the origin 0, 0, and I'm going to call it O again, just like the last one. But this time it's with a scale factor of 1/2, not 3. Okay, so let's say I'll do this. I'll make a line segment AB. I'll put A at 0, 4, and I'll go ahead and put B at 4, 4. Okay, so now I have this line segment. But now we're going to go ahead and dilate it with a scale factor of 1/2 at point O. And point O, I've already indicated, is at the origin, 0, 0. So there's point O. Now, the distance originally from O to A, or A to O, that has a length of 4. Okay? Well, didn't we get a scale factor of 1/2? Yeah. So what's half of 4? Okay. Well, we have 4. That would be half, 2, right? Right in the middle. Okay. So we just halved 4 into 2. And let's look our distance from O to B, or B to O. It'd be right here also. Okay. So I think we just found our new coordinates. So I'll do this one in blue. A prime is going to be at 0, 2. And B prime is going to be at 2, 2. So here is our answer, okay? Our transformation, okay? So after you dilate AB by a scale factor of 1/2, notice how it gets smaller, okay? And the scale factor already tells us that A prime, B prime is going to be half the size or half the length of AB. And you can use the coordinate system to double check. You can tell that your length for AB was 4. but your length for A prime, B prime ends up being 2. Okay? 4 is, well, 2 is half of 4, and that makes sense because our scale factor is 1/2. We just halved the original length. Okay? And we do that in real life with construction, projections. The projector in the classroom, for example, goes through this math. For example, the screen I'm working on right now, it's about 10 by 7 inches, 10 by 8 inches. But your computer that you're looking at right now, if you have it maxed out on your screen, it's probably what, 12 by 8, I'm assuming? Okay, so it already goes through a digital dilation. All right. Example 4. We're going to deal with a triangle ABC, with a center dilation at point C. So, let me go ahead and draw our triangle. Factor of 2, so I'll go ahead and draw my triangle. Let me use more interesting color. Yeah, it's a good contrast. Just sticks out like firecrackers. All right, that's a terrible, terrible drawing. There we go. That's a little better. All right, well, that's good enough. All right, so here is point A at 0, 2. Here is point B at 2, 0. And here is point C, okay, at 0, 0, aka the origin. So, if we're going to dilate our triangle with a scale factor of 2, okay, at the center of dilation at point C, well, if we do this by 2, notice how your distance from AC is, a distance of 2. Well, scale factor of 2, what's 2 times 2? What's twice of 2? That's 4. So your new triangle, ooh, green's a nice contrast. It's going to be twice the length, okay? So your new point for the pre-image point of A prime, is going to be at 0, 4 instead of 0, 2. Let's look at B. Okay, where's the new B prime going to be? Well, if you notice, the distance between C and B is also 2. And again, our scale factor is 2, so what's twice of 2? That's 4. Twice the distance. So B prime is going to be right there. Oops. My brain is already jumping ahead. Okay, and C, well, C's just there. Okay, so you just relabel them. What's 0 times, what's twice of 0? What's 2 times 0? 0. He stays there. And that's kind of the funny joke about projecting onto just yourself. Nothing's going to happen. You have to have distance. Okay, C does not have distance. So your new image, I'll make sure I draw this right. Your new image is the green triangle. Okay, that's what happens to objects on a coordinate system. Also notice the scale factor idea. Originally, A. Okay, I'll write it over here. Now let me do a nice little color coding aspect to this. A was originally at 0, 2, yes? Now when you dilate from point C this will happen to you. So when we dilate, okay, that's D for dilate, all you're doing for A prime is you're taking your scale factor, okay, and I'll go ahead and remind you our scale factor was 2. You're just multiplying. You're just multiplying 2 times 0 comma 2 times 2. And that's actually how you get, algebraically, your new point, which is at 0 comma 4. If you don't believe me, try doing it for all the other points, okay? And you're going to see that pattern, okay? For B, 0 comma, or 2 comma 0, all right? So your x was 2. What's 2 times 2? 4. Your y was 0, because it's 2 comma 0. What's 2 times 0? 0. So your new point for B prime is 4 comma 0. So that's what happens algebraically and with the rules, okay? So the rules, again, let me just write it here. You have a point, okay? You have an x, you have a y. When you dilate, we care about your scale factor. So your new point is going to be the scale factor. Let me use a different color. I'll pay homage to my winter break with the Christmas theme color. Is k times x, comma, k times y. Okay, that's a rule for dilation. Okay, that's a rule. And I don't think the book put too much emphasis on this. Do I feel that it is significant enough to mention? Obviously. So at least write that rule down. Box it, just like how I did. It's fairly significant in math. And it's always one of those nice little rules that if you just have it in your head, it won't be as confusing sometimes, especially to remember. Because, we forget things. All right. Example 5, dilation of a triangle ABC with a center of dilation at point C with a scale factor of 1/2. So let me go ahead and draw again. This time I'm going to do a little bit faster. So let's say we have, yeah, sure. Let's say we have a triangle. Okay, like this. A is right here. B is right here. And C, our center of dilation, is at 0 comma 0. Now, you can go ahead and use the rule if you like. That would probably make it simpler. But I'm just going to go ahead and do this visually for most of you. So, scale factor of 1/2. Our distance from AC is originally 4. Okay, so what's half of 4? 2. Okay. Let's look at B, the distance from B to C. Their distance is also 4. Okay, remember distance can't be negative, so don't get thrown off by the second quadrant x values. So what's half of 4? And again, that's just 2. So your new triangle is going to be smaller. Okay, it compressed. So that's the answer, the green triangle. All right. And there's one, I believe, in your homework that's like that. Oh, a couple. Okay, I think one's going to use a ruler but the idea is the same. All right, the distance is just either growing or shrinking by the scale factor. All right, properties of dilations. First things first, dilations preserve angle measurements. So just like the triangle in the first example, the degrees stay the same. Okay. Dilations preserve betweenness. You dilate a circle, you're still looking at a circle after you're done. All right. If something happens and it doesn't look like a circle anymore, something's wrong. Okay. Dilations preserve collinearity. So remember when we graphed our triangles. Okay. And we ended up dilating. Okay. And I'll go ahead and make a shrinking aspect of dilation, like a scale factor of 1/2. Notice how the lines are all parallel to each other, or they exist on the same line as the other one. That's what it's talking about. It should be somewhere. It shouldn't be like, like that. That's definitely messed up. Okay, and that probably leads me into our next property. Dilation preserves orientation. Okay, so your projector is broken or a setting is off when you project a let's see. When you project a smiley face, and all of a sudden you dilate it to your projector screen, and all of a sudden it's an upside down smiley face. All right? The projector is obviously reflected, and you have to go to settings and change all that. Dilations map a line segment, the pre-image, to another line segment whose lengths are the product of the scale factor and the length of the pre-image. And that was the rule that I discussed briefly with you. Okay? You have a point at x comma y, and then after you dilate that point, the only thing that happens is you use the product rule on that point or coordinate, and you multiply by the scale factor, which is belovedly known as k. Okay. Now, your next property just says dilations map a line not passing through the center of dilation to a parallel line and leave the line passing through the center unchanged. So if you remember, if it's at the origin, if you multiply the scale factor to 0, 0, it's still going to be at 0, 0. C is still going to be where C prime ends up being. Okay, nothing changes. Okay, that happens. All right, here are some questions for you. I want to go ahead and when you turn in this assignment on Haiku, just answer it and turn it in. Do dilations appear to preserve angle measurements? So remember my example 1. Okay, do they or do they not? Second question, do dilations appear to preserve distance? Do the distance stay the same or do they change? All right, and that comes along with, does it get bigger, smaller, that kind of question. What happens when you dilate with a scale factor of 1? Now, if you remember the rule, multiply by 1. What do you notice about the points? Okay, that's what I want you to answer. I want you to answer these 3 questions, turn in the assignment on Haiku, all right, after you've watched this. That way I know you actually followed through with watching the video. I'm still debating about putting subliminal answers into my videos just for you guys for your quizzes. So pay attention to detail, guys. Here's your homework, 1 through 15. Let me know if you have any questions. Good luck.